Good day, good people. Let us look at hydraulics. Let us look at hydraulics, good people. Right. We will be looking at the application of Pascal law. Whenever we talk hydraulics, we talk Pascal law. Now, let's look at the definition of Pascal law. This would be the definition. Let's look at the definition of Pascal law. The definition says, when a pressure is exerted on the surface of a liquid, this force is transmitted with the same intensity through the liquid in all directions. Meaning, when the force is exerted here, the force will be transmitted with the same intensity throughout the liquid in all directions. Meaning, if here on the plunger side, we've exerted 10 kilopascal, that pressure or the force will be transmitted throughout the container with the same intensity. If here there's 10, that means here there's 10 kilopascal as well. That's what Pascal here is saying in short. Now, one of the characteristics of pressure in a liquid, we are told that pressure does not depend on the shape and size of the container. From this application, you can tell that the plunger side, it's a small side, and the ram side is the big side. Now, pressure does not depend on the size or the shape of the container. It depends on the content in that system. Now, in this system, it depends on the liquid in this system, all right? Then another characteristic says, and if that's the case, it means pressure on the plunger equals to pressure on the ram. Now, how do we then calculate pressure? In calculating pressure, it is force over area plunger, then equals to W over area ram. Now, we will be denoting our force on the ram side as W, because if objects are acting against gravity, we'll denote them as what? As W. And how do we calculate the W? It is mass multiplied by gravity. Okay. Then in manipulating and making and taking the forces to be on the same side, it will be W over F equals to AR over AP. Now, the force here, it is this force here, it is force load. Now, it will be FL, okay? It is the force load. Now, this is the formula that we'll be using to calculate whatever that they want us to calculate. And this formula, you can tell it is taken from Pascal law or the characteristics of pressure in a liquid. Now, if you are given diameters and you are not given the areas, there's no need for you to convert the diameter into an area. By the way, how do we convert diameter into an area? You apply the formula, it will be pi d squared divided by 4, then you get the area. But if you are given the diameters, now this formula would be W over F load equals to big D squared over small d squared. Now, the pi and the pi, if this is the plunger, on the ram you are having the same thing. The pi and the pi will cancel out, the 4 and the 4 will cancel out on this formula. Then you'd realize that you are left with d squared and small d. Now, this formula as well, it is applicable. If you are given areas, you will use that formula. If diameters, then you will use that formula. Then we then have to look at the equipment itself. In looking at the equipment itself, the equipment gives you the mechanical advantage. You are able to do much of the work applying what? Less force. Now, in calculating the mechanical advantage, this is the formula that we are using. Mechanical advantage equals to force load, this force, it's a built-in force, over F effort. The F effort, it is the force that you apply on the handle. It is human ability, and it is always assumed to be at 100%. Now, the F load, the fact that it's a built-in, it is affected by efficiency. Okay, it is affected by efficiency. This is the formula that we'll be using to calculate mechanical advantage. But working from the rem side to the plunger, it will be W over F load. This formula as well, it is applicable, right, in calculating the mechanical advantage. Those two formulas, they are applicable. Now, let's work out the concept of mechanical advantage. Let's work out the concept of mechanical advantage while you are given efficiency. Right, remember we said mechanical advantage equals to force load over F effort. Right, F effort, it is assumed to be at 100%, then efficiency, it affects F load. And how do we calculate efficiency, by the way? Efficiency, it is power out over power in, or it is work output over work input. That's the formula that you'll be using to calculate what efficiency. Now let's talk a bit about the efficiency and the 100% part of it. Let's say you are given the data. On the given data, they want you to calculate W, right? And the W, it is taken from that formula, FL over big D squared over small d. Right, then in manipulating the W, it will be F load multiplied by D squared divided by small d. Now, we don't have the FL. For us to be able to calculate the W, we first have to calculate the FL. We then have to use this formula in calculating what the W. We have to first calculate FL. That means we need to make FL the subject of the formula. Let's say you are given the efficiency, it is 80%, okay? Then you are given mechanical advantage, it is 12. Then you are given the F effort. You are given the F effort, it is 310 Newton, okay? Now let's work out this concept a bit. Right, let's work out this concept a bit. Okay. Now in working out this concept, this is what you would realize, or in applying the efficiency and the 100%, okay? Now, in making FL the subject of the formula, it will be FL equals to MA multiplied by F effort. F effort. Now it is 12 multiplied by 310. But please make note, this F effort, it is at 100%. Okay? Since what we said, we assume the F effort to be at 100%. It means the FL, it will be calculated from the 100% that the F effort is. It means the FL, it will assume the 100% of what? Of F effort. It means the answer that you will get here, it is at 100%. 12 times 310. It gives us 3,720 Newton. This force, it is at 100%. Why? It is because of FL has assumed the 100% that F effort is. And yet we are told that our equipment is operating at 80%. It is 80% effective. It then means we need to reduce this force to 80%. How do we do that? We will then multiply by 80 divided by 100, or you can multiply by 0.8. Then you get your answer as 2,976 Newton. Right. Now, we have managed to step down this force to 80% because our machine, it is 80% effective. If we were to apply this force in our machine, we will cause more damage because already our machine has worn down or you know, it is the effectiveness of the machine, it is reducing from 100% to 80%. Now, this is how you work out the efficiency part of it. Vice versa, it is true. Let's say we are calculating, they want us to calculate the F effort. Now, in calculating the F effort, it will be MA equals to F load over F effort. They want us to calculate F effort. Then when we make F effort the subject of the formula, it will be F effort equals to F load over MA. Let's say our F load, it is given as 2,100 divided by the MA, it is given as 12. Now, the fact that the F load, it is affected by efficiency, and our efficiency, it is 80%. This is what you would realize. You would realize that our F effort, it will be at that 80%. It will assume the 80% that the F load is. It means our answer here, 2,100 divided by 12. It is 175 Newton. This force, it is at 80%. And we said it that F effort, it is always calculated from what? From 100%, because it is human ability. That means we need to step up this force to 100%. You will then say multiply by 100 divide by 80. Then it will be multiply by 100 divide by what? By 80. Divide by 80. Our answer now, it is 218.75%. Now, we've managed to step up the effort from 80 to 100%, because the 100%, it is human ability. It has to do with your ability as human. Now, hence we are assuming it to be at 100%. Now, this is how you work out the concept of efficiency, F load and F effort. Stepping it up and stepping it down. That's how you work it out. Now, let's do some application. Let's look at this given information here. An effort of 210 is applied. Let's take out the data, the given information. We are given the F effort. It is 210 Newton. Is applied on the lever of the hydraulic press. Like I said, that this force applied on the lever, it is human ability. It is your ability. Now it is assumed to be at what? At 100%. All right. The stroke length, we are given the stroke length, it is 120 mil. That would be 0.12 meters. The mechanical advantage, we are given the MA, it is 18. Then we are given the diameter of the plunger, it is 110 mil. That would be 0.11 meters. Then we are given the big D as well, diameter on the ram, it is 290 millimeters. This would be 0.29 meters. And what else it is given? Yes, that's what's given there. Then they want us to calculate the mass. Now, with the given information and the given question, the first thing that you need to do is to write the relevant formulas. The formulas and the data will indicate for you how to tackle the question. The data will indicate for you which formulas to use, then the formulas will lead you to the precise and the correct solution. Now, in calculating the mass, we know that in calculating the mass, we have to calculate our mass from W, because it is mass multiplied by gravitational force. We now know which formula to use. It is W over F load equals to D squared over small d. Then we want the W so that we can get the mass. Then it will be F load multiplied by D squared over small d. But in this formula, you can tell that when we compare the given information and the formula, we realize that we don't have FL. Now, for us to be able to get the FL, we then have to use this formula. Mechanical advantage equals to F load over F effort. We then have to make F effort the subject of the formula. Remember, this one it is affected by efficiency. This one it is assumed to be at 100%. Now, we are looking for FL. In calculating the FL, it will be FL equals to MA multiplied by F effort. Our MA, it is 18, multiplied by F effort, it is 210. This 210, it is assumed to be at what? At 100%. Don't forget that. Okay, it is assumed to be at 100%. Then we get our answer as 3,780 Newton. Now this force, it is at 100%. We then have to step, it is at what? 100%. And we are told that we have the efficiency, and the efficiency is given as 93%. Our machine, it is 93% effective. It means we need to reduce this 100% to 93. Then we are going to multiply by 93, divide by 100. Then we get the force at 93%. It means the force, it will be 3,515,4 Newton. We then managed to reduce that force from 100% to 93 because our machine, it's 93% effective. We can then take this force in that formula. Then it will be 3,515,4 multiplied by big D, 0.29 squared, divide by 0.11 squared. Then we get our answer as 24,433,483 newtons. Now, this is what we have. This is our W. For us to get the mass, we then have to divide by 9,8. Then our mass, it is 2,493,23 kgs. This is how you tackle this question. Then the second question, let's look at the second question. Let's wipe here. The second question, they want us to calculate the number of strokes. They want us to calculate the number of strokes. Now, in calculating the number of strokes, it is easy, straight to the point. Now, this is the summary because I wanted to tackle the given question. Now, in calculating the number of strokes, this is the formula that we'll be using. VP equals to VR. Now, you can predict it this way, or you can calculate it from the efficiency. Efficiency, it is power out over power in. Because the question says, calculate the number of operating strokes if the object in question A is lifted, we are given the height, it is 410, and if the efficiency is 93. Now, it will be power in over power out, right? Now we know that work out over work in, work out over work in. In calculating the work, it is force multiplied by V, right? It means it is force, it is common, it will be V out over F over V in. The F and the F will cancel out. But we are given what? The efficiency. It means now you are having efficiency equals to work out over work in. Hence the force and the force will cancel out. And now this is what we have then here. We are having efficiency equals to V out over V in. Then when you cross multiply, it will be efficiency multiplied by V in equals to VO. Then it is efficiency multiplied by small d squared ln equals to big D squared multiplied by height. We are looking for n, then n would be big D squared multiplied by h divided by efficiency multiplied by small d squared multiplied by L. Then we are having n equals to big D 0.29 squared multiplied by 0.41. The height multiplied by 0.93 divided by 0.93 multiplied by 0.11 squared multiplied by 0.12. Then we get our answer. We get our answer as 8,000 719, then in rounding it off, it will be 9 strokes. This is how you tackle this hydraulic problem. Thank you, good people.